Sweet tot innocence, who give me some popsicles tonight? Oh, oh, hello. I didn't realize you were there. But hi, everybody. It's Voltar here, and I want to talk about something that I've been meaning to discuss for quite a while now. Now, there are a plethora of SCART cable options available to us today. Some are good, some are bad, and others can be downright dangerous to your equipment. Now, I want to spend a little time to discuss what could be potentially dangerous to your video chain or setup. Specifically, I'll be discussing Genesis RGB cables that may be advertised as having boosted sync. Ultimately, I'll show you how you can correctly rebuild these boosted C-Sync cables so that they're proper and healthy to your video chain. Now, this video might get awfully boring to some of you. It's going to be very breathy with a lot of technical stuff. I believe it's important for people to have this information and be thoroughly informed. So let's tear into one of these boosted C-Sync cables, which I actually kind of already have here. So we'll tear into this, we'll find out what's happening electrically, and we're going to get to the bottom of it all. Sit back, strap on, and let's do it to it. Okay, so we're looking at the cable here, and I've actually already started dissecting the circuit here that boosts or buffers the C-Sync in preparation to repairing this cable, but that's fine. This is still very easily explained. So what we have here is we have this little SOP to DIP adapter board that has what a lot of you are familiar with who do any sort of RGB modding, for example. On this board is a THS7314, and what's happening is that the composite sync optogenesis is going into one of the inputs of this video driver, and it's being doubled up on the outputs, and that's why they call it a boosted C-Sync. Now, the 7314 is a 3-line SD video driver, so it's designed primarily to buffer and drive SD video content. That means anything from composite video to S-video, and of course analog RGB. Now, this amp has a fixed gain of 2, which means that whatever voltage or amplitude is being placed into its inputs, that will be double in size as it's driven through the outputs. So does that mean that a 5-volt C-Sync signal, for an example, turns into a 10-volt C-Sync signal? Well, not quite. The THS7314 is powered by the 5-volt supply from the Sega Genesis. Therefore, the peak voltage output remains at 5 volts. Now, you have 2 rails in the Sega Genesis. You have a 5-volt supply from the 7805, and you have 0 volts, which is ground. Now, we call these power rails, and the 7314 is a rail-to-rail amplifier. Now, so the 7314's output is limited between these two. So what does happen, though, is the C-Sync signal becomes grossly saturated as it's buffered to 5 volts peak. The signal will clip and become distorted, and that's not good for anybody. So the Genesis C-Sync is a logic level signal. It's TTL, so 5 volts means it's on, 0 volts means it's off. The composite sync outputs at a nominal 5 volts. Now, the signal was never designed to be utilized by consumer-grade equipment, or more specifically, equipment that's designed to be used with 75 ohm transmission lines, such as your television. Now, without getting into all of the serious technical mumbo-jumbo, a safe haven for composite sync is anything between 210 millivolts or 0.2 volts to right under a volt or 950 millivolts. So we'll say anything between 210 and 950 millivolts. Now, just for reference, composite video should be 1 volt peak to peak, which is including the composite sync data at 75 ohm impedance. Now, 5 volts off the Genesis is way off from the standard we just specified. Now, is that a big deal? Well, yeah. The objective here is to attenuate the 5 volt composite sync signal out of the Genesis to a lower level that's pseudo-compliant with NTSC PAL transmission line standards. So if the objective is to lower the amplitude of the Genesis composite sync signal, what in the hell is the point of these boosted C-Sync cables that are trying to effectively double the signal amplitude? Well, only God knows why, and I really don't have a good answer for you. So the XRGB Mini uses an ADV7441A video decoder to capture video from the inputs of the device. Now let's take a look at some of the application data for this chip. So here we're looking at the datasheet for the 7441A. Now, composite sync goes into an analog input of this device, so we're most interested in looking at the analog supply. And as we can clearly see here, we have 1.8 volts as the typical norm. Now let's take a look at the maximum rating specifications. And here's the max, 2.2 volts. Now if you read in this red box below, exposure to this absolute maximum rating for any extended duration may affect device reliability. So knowing this, boosted Genesis C-Sync cables are clearly violating the specifications per the datasheet. So we've removed the 7314 from our Windows 3.1 paint graph. We're using a 470 ohm resistor and a 10 microfarad capacitor to more properly drive this logic level C-Sync signal into our 75 ohm impedance equipment. Now if you remember from earlier, it's best to allow your composite sync signal to live between 210 and 950 millivolts. If we use a 470 ohm resistor, this will yield an amplitude of approximately 520 millivolts, which is optimal for all equipment. Now the 10 microfarad capacitor is just our method of isolating the signal from the console. This will keep the console from being pulled down if we plug this cable into some wonky, junky device that blows. Okay, so we have here the composite sync output from the Genesis. It's this yellow conductor here. This resistor here is our 470 ohm resistor that we'll be using to limit current and to attenuate. And this is our capacitor, our 10 microfarad capacitor that we'll be putting on the end. So now that we have all of our components together, let's just get the old soldering iron out and let's just rebuild this cable. Also, I want to mention polarity here. Make sure that the positive side is facing towards the console. So between the resistor off the composite sync output and the cap, positive mates to the cap, or positive mates to the resistor, and the negative side of the cap that'll attach to the that'll terminate to the SCART connector here. So let's just do some measuring here. So I have my resistor soldered in, and I'm trying to find out what would be ideal. So let's put some slack in here so we can have some headroom. I think right about there is pretty good. So what I'm going to do is I'm going to come right in here, and I'm just going to cut everything down like that. There's our resistor, and let's measure again. So we've got our resistor here, and we're seeing where that's going to live, and that's going to live about right there, which is just fine for our needs here. So what I'm going to do is I think I'm going to bend this and invert this leg so that it's adjacent to the can. So what'll happen is that the can and the resistor are all in line, just like that, and you'll have the lead soldered here, and then you'll have the resistor soldered just like that. So to do that, I think what I'm going to do is I'm going to reach in my little special drawer here for special occasions. I'm going to grab a piece of heat shrink. Not super necessary, but this is going back to a good friend of mine, and I just want to make sure that no shorts or anything like that. And of course, if you are building these cables professionally, I highly encourage you to kind of do this by the book. So at any rate, let's go ahead here and let's solder in our components. So what I'm going to do is I'm just going to come right in here, and I'm going to pre-tin this little passive resistor here. That's pre-tinned. I want to come here to the this cap. I'm gonna flex that up just a bit there. I'm gonna introduce a little solder here. Whoops. Alright, so here we go. Just gonna come down with it, and 1, 2, 3. Perfect. Nice and pre-tinned. So now that we have that in place, I'm just gonna come right here. I want to join these two just like this. Come in here. You really can't see this that well. I apologize, but that's not the point. It's just showing you the proper components. And 1, 2, 3. Here we go. So there we are. We got everything fairly well lined up. I'm just going to come in here and I'm just going to tack it in. Just like that. See if I can get a close-up of this. But nice wetted joint just like that. Everything's well attached. And now that we've done that, I want to come here with my heat shrink. I'm just going to bring this down so I can gauge how much I want to cut off, because I do want to isolate this cap just for good measure. So I can see it's coming out right here. So I'm going to cut about where my finger is, right here, the edge of my thumb. Cut this down. Introduce this in here like so. Before I heat shrink this down to have this constrict against the can, I'm going to go ahead and I'm going to come right in here. I'm going to make sure I got a good solid connection here. So what I'll do, again, is I'll just come right in here with my soldering iron. I'm going to fill this cup, this solder cup here on pin 20, which is the composite video or C-Sync output. We've got that nice and filled. I'm just going to drop a bit of no clean in there. I'm going to come right here and I'm going to position this component leg of the capacitor right over top of this. Make it nice and flush against it, and we're going to introduce a little heat so we get a nice solid wetted wale here. 1, 2, 3, 4, let go. Beautiful. So if I bring this in here, you can clearly see that is a beautiful joint. It might have been a little blurry. So what I'm going to do now is I'm going to scoot this up just like that. We're going to get some heat going here. Okay, very good. I'm going to come right in here and we're just going to shrink this down. Just like that, just like that. Attaboy, 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 attaboy. And that's all there is to that. Again, you know, the heat shrink is just, you know, I think it's a good practice. Just keeps everything nice and insulated. But there you go. I mean, you've got your 470 ohm resistor in there, and you've got your isolation capacitor. The polarity is correct. Remember, the positive side of the capacitor faces the console. The negative attaches here to the SCART connector, and that's it. And I'd also like to add that this whole process, this information, is not only applicable to Genesis systems, but master systems too. So if you have a master system cable that was purchased as a boosted C-Sync cable, all of this is applicable. So that's really it, guys. I mean, this was a really short, super boring video. Not the best shot video. You know, I've been working on this for a while, actually, off and on, just about how to really sort of explain this stuff reasonably well, without being too technical or being losing too many people, because this is important. You know, it's not to poke fun at anybody. It's not to be shameful or anything like that, or to shame anybody. It's just a matter of putting this stuff out there so that not only you, the consumer, know what you're buying, but cable manufacturers from eBay to AliExpress to anywhere, they have better information with actual data backing it up so they can do a better job at building these cables. And I don't want that to be misconstrued, so that's clearly what we're doing here. At any rate, guys, I hope this video helps you. You know, I hope that you know, you're doing well in life. You know, like and subscribe if you like the video. That certainly helps. Suggestions, put those down below in the comment section. And, you know, Lord Voltar appreciates your bodies. Thank you.